Okay, for number 3, it says let x, y, and z be positive real numbers that satisfy the following 3 equations, by the way. Now the question is what's the sum x, y, y, z, and xz, all right? So I guess you could solve for x, y, and z and then just multiply it out and add it together and get this thing over here, but I think it might be an easier way of doing it. Again, I'm not really thinking that x, y, and z are going to be easy to find, but maybe the products x, y, y, z, and xz will be easy to find. All right, you could do it through elimination maybe, I don't know. Let's take a look at it with a whiteboard and write down what they've told me. And again, it's important you have the document in front of you so you can read it, and I am reading it over here. It's number 3. I consider this to be a tough question. So x, y, and z are going to be positive real number. They satisfy 3 equations, by the way. You get 3 equals x squared. I'm going to write a little bit differently. Plus y squared plus xy. I'll write that number 1 down, and the number 1 is, let's see, y squared plus z squared plus yz. There's definitely a pattern to it. And 4 is equal to, let's see, I'm going to say x squared plus z squared plus xz. Again, how do you do this? I guess you could solve for x, y, and z, right? Then get this up. Someone says, what do you want? I want to find out what xy is, what yz is, and what xz is. And if I knew those 3 things together, I just add together and I get what they want. Okay, what I'm going to do is look at this thing over here and start to realize that I'm seeing those numbers 3, 1, and 4. And I'm starting to recognize those 3 numbers as being related to a triangle. All right? I want to point out the relationships I'm seeing over here is the root of 3. I do recognize the number, by the way. Is x squared plus y squared plus xy. And the root of 1 is 1, and that's going to be equal to the root. And this is fine because these are positive real numbers. So all these things are going to be nice to do. When I say nice, I don't have to worry about complex numbers. The root of 4 is 2, and that's going to be this thing over here, x squared plus z squared plus xz. All right. I recognize a triangle. Let's put this down. One, 2, root 3. And this is a 30, 60, 90. All right? So I recognize that. Of course, I'm recognizing this, and I'm trying to get the relationship between those, polynomial equations and this triangle. And what I'm going to do is, I'm starting to think maybe this has something to do with the law of cosines. Maybe. And the way I'm going to do that is I'm going to take a point in the center, not center, but this thing over here, and I'm not going to send a terribly good picture at this, but something like this over here, where I'm dividing that into 3 equal angles of 120 degrees. So they're all equal to 120 degrees. This is 120, that's 120, that's 120. All right? And then what I do is look at the root 3 and realize that maybe it's a law of cosines. And the root 3 is related to x and y. So I'll put x here and y over here. Let's write this down. So it's going to be root 3 squared. I'm using the law of cosines. X squared plus y squared minus 2 times the cosine 120 degrees times xy. Just using the law of cosines. Does that give us what we want? It does, because the cosine of 120 degrees is minus 1/2. So we would get back x squared plus y squared plus xy. All right? Pretty reasonable. Let's keep going. Let's just see if the next one works out. And the next one, I'm looking at a relationship between y and z, and that's with the number 1. So I'll put this z over here. So what do you get there? 1 squared is 1. You get z squared plus y squared minus 2 cosine 120 degrees zy. Does that give us what we want? You get z squared, you get y squared, and again, cosine of 120 degrees is minus 1/2, so you get plus yz. And that works out good. Let's do the next one. It's already labeled for me. That's going to be 2 squared, which is 4. That's going to be x squared plus z squared minus 2 cosine 120 degrees xz. Does that give us what we want? It does. It gives us x squared plus z squared. And again, the cosine of 120 is minus 1/2, so you get plus xe. So everything's working out fine, by the way. All right. The next thing I'll talk about is, I'm wondering how to get this to give me the xe, yz, blah, blah, blah. All right. So what I'm going to look at is I'm going to look at areas. And the area of the big triangle is going to be the area of those three separate problems over there. So what's the area of the big triangle? It's 1/2 times the base of it. And what's the base going to be? It's 1. And the height is √3. All right, let's do one triangle at a time. And the question is, the triangle, which triangle are you going to do first? Let me make sure I'm reading the problem right. X, Y, Y, Z, X, Z. And they do want to know what that sum is. And I'm looking at this and I can put the areas down. And I'm hoping I can do that. So let's write this down. So it's going to be, let's do one triangle at a time. And I'm going to do, I don't know, maybe this one first. Let me get my highlighter out. Let me do that one first. The area of that one. So it's going to be 1/2. Let me think about that. That's 120. I'm doing the height of it, the base of it. Again, if we got, sort of like a triangle over here, something like this over here. This is H, A, B, and C, right? So what do you get over there? This is going to be the sine of that angle, by the way. The sine of that angle. I'll just call it theta, by the way. It's going to be H over A. So A sine theta would equal H. And the area would be 1/2 times the A sine theta times the base of it, which would be C. So I think I can do that. Let's write that down. So 1/2 AC would be YZ now. And the theta there would be 120, right? So sine of 120. Well, that's encouraging news. I'll tell you why. But I do see YZ now. Let's put the next one down. 1/2. Let's do this guy over here. And let me just get the highlighter out for you. We're doing this guy now. Oops, I meant highlighter, right? We're doing this triangle now. Back over here. 1/2. What's that going to be? That's going to be YX. Sure I did that right. Yeah, YX, the sine of 120. All right, let's do the last guy. Plus 1/2. Let's get the highlighter out again. We're doing this guy over here. Let's see what that, I have to look at it again. XZ, sine 120 degrees. All right, let's multiply both sides by 2. You get √3. You get YZ. The sine of 120 is √3 over 2. Plus, again, I multiply both sides by by 2 already. So you get XY √3 over 2, and then you get XZ √3 over 2. I'm going to divide both sides by √3 and multiply by 2. So 2 would equal YZ. I got to go back and read the question again too to make sure this is what they wanted. Get back at the question. What they want? What's the value of XY, YZ, XY, YZ, and XZ? We got it. It's 2. And we're done. Thank you.